So now that we've covered graphing some basic logarithmic functions, I've got these examples where we graph logarithmic functions that are going to involve applying some transformations. Okay, so a good way to do this is to start by graphing the parent function, which I'd like to graph in gray here. So for example A, the parent function will be log base 3 of x. For these logarithmic graphs, you always want to use a parent graph or a parent function of this form, y equals log base b of x. And so what's going to vary from problem to problem is what your base is, this base b. So in this case, the base is 3. The graph of y equals log base 3 of x will include, so 2 points and an asymptote are what we want to keep track of. If x is 1, then y will be 0, because 3 raised to the 0 power will give you 1. And if x is 3, then y is 1. Remember that the log function is always, it's solving for the exponent. So it's always what power of 3 gives me whatever this x value is. So what power of 3 is 1? The answer is 0. So the y coordinate here is representing the exponent. And what power of 3 is 3? That's the first power. And then a vertical asymptote at x equals 0. So we can real quick slap a parent graph on this grid. Vertical asymptote at x equals 0, this point at 1, 0, and then 3, 1 right here. And there's rough sketch of log base 3 of x. Now we need to track the transformations that need to happen. And did that work? No, it didn't actually change. I'll have to use the green. So to transform that log base 3 of x into the graph for this equation, let's see. So the plus 2 inside the parentheses, that represents a horizontal shift. And horizontal shifts do sort of the opposite of what you expect them to do. So plus 2 is actually going to go left 2. It goes sort of backward 2 units. And then the negative in front, that's going to be a reflection. Because the negative is in front, it's outside of that log function, it's going to reflect vertically. So it's going to reflect over the x-axis. Okay, so we want to do those two things to each of these three key features. So I always like to start with the asymptote, because to me the asymptote is sort of the thing that affects the graph the most. If I reflect that over the x-axis, it's just going to reflect onto itself. It's not going to look any different. But if we shift it left 2 units, that is going to make a difference. So now if we move that whole asymptote left 2 units, then it's going to land here. Now I want to do the same thing to this point at 1, 0. So reflect over the x-axis. Well, if it's on the x-axis, again, it just sort of reflects onto itself. And then shift left 2. So it lands here. This point, reflect it over the x-axis. Okay, so finally something's going to change. That's going to flip the y from positive 1 to negative 1. And then shift left 2 units. So that's going to move it here. So it's these 2 points and this asymptote here. Let me get rid of this thing that I drew earlier. Get rid of some of this extra stuff. Okay. So the final graph looks something like this. I don't want it to look like it's got an asymptote over here. It's just it's decreasing very slowly. But so the curve in green is a rough sketch of the graph of this equation. Now I know that in some of your homework questions, it's also going to ask you for domain and range. So let me go over that real quick. Domain is the set of x values included in this graph. So there's this vertical asymptote at negative 2. X equals negative 2 would be the equation of that asymptote. The graph gets really close to that vertical asymptote, but never quite touches it. So the x values go right up to negative 2, but don't quite reach negative 2. So you need a parenthesis there. And then as far as highest x value goes, well, that's going out to infinity. Range for basically all of these log functions is all real numbers, negative infinity to infinity. This graph is going to cover all negative y values eventually. It takes its time getting down here to these real big negatives, but it'll get there eventually. And then all positive y values going that way. All right, so there's your domain and range. Now for this second equation. So 2 plus log base 4 of x minus 1. I want to again start with the graph of a parent function. So log, keep the same base of just plain old x. That graph is going to include, so again, 2 points in an asymptote. It's going to include the point 4, 1, and the point 1, 0. So B1, 1, 0, and vertical asymptote at x equals 0. So vertical asymptote at x equals 0, 1, 0, and 4, see, 2, 3, 4, 1 here. So parent graph looks something like that. Now we apply transformations to change the parent graph into the graph of this equation. So the minus 1 here indicates a horizontal shift, because it's inside the parentheses. That's going to be horizontal change, right 1 unit. Again, those horizontal shifts do the opposite of what it looks like it's going to do. So minus 1 actually is going to go forward 1 unit. And then plus 2 outside of that log function. So when it's outside, that indicates a vertical shift. And vertical shifts are not tricky. Vertical shifts are straightforward. Plus 2 goes up 2 units. Okay, so I'm going to do those 2 changes to each of these three key features. I have such a hard time saying that. The asymptote and the 2 points. So I'm going to start with the asymptote again. I've got this vertical asymptote here. I shift it right 1 unit, so now it's here. And then shifting that vertical asymptote up 1 unit makes no difference. Because imagine this vertical asymptote extends to positive infinity and negative infinity. It extends forever in both directions. So shifting up 2 units makes no change in the graph. With this point, that is going to make a change. So take this point, go right 1, and then up 2 units. So it's going to land here at 2, 2. This point goes right 1, and then up 2 units. So I've got this double spaced 1, 2. I do this a lot where it kind of runs into the words I wrote. I'm going to get rid of this. Okay. All right, so these 2 points and this vertical asymptote. So the graph final answer looks something like this. And let me go over that with a highlighter just to distinguish it from the parent graph. So it's something like that. That function has a vertical asymptote at, it used to be x equals 0 for the parent graph. We moved it right 1, so the vertical asymptote for this function is x equals 1. And it's got domain 1 to infinity. Used to be 0 to infinity. We moved everything right 1. Now the domain covers x values from 1 to infinity. And range, again, is going to be all real numbers, like it is for basically, or for every logarithmic function that you guys are going to graph, the range is going to be all real numbers.